So today we're going to talk about a concept of bionic prosthetics. So prosthetics have been around for a while. They've been used for a long time in patients who have lost limbs, specifically arms or legs. However, recently they have come up with technology to make these limbs more lifelike. So these people are now able to have limbs that they can control potentially with their own thoughts as if they would their own limbs. This has transformed the lives of these patients, and the technology is incredibly fascinating. So we're going to go into some of the details on how this new technology works and give an example of a patient whose life was changed because of this.
So neural implants and interfacing help bionics this way. Neural implants are technological devices connected directly to the brain. Neural interfacing is full of systems operating at an intersection of the nervous system and internal/external devices. The purposes and goals of using neural implants and interfacing with bionics is that they allow amputees to receive tactile feedback from prosthetic devices, and they're able to move them without deliberate thinking. And wireless interfacing between bionics and the nervous system is something new that's coming up.
Okay, so now I'm going to introduce a man who goes by the name of Dennis, who is a real-life example of using these new prosthetics and how it changed his life. So Dennis was involved in a very unfortunate fireworks incident in which he actually blew off his left arm and wounded it so badly that he had to have it amputated. Now, he worked with an original prosthetic for a long time, and then recently he was approached by some researchers to be the first person to test a new prosthetic hand. The goal of this new hand was for him to be able to recognize different objects by their touch, by their the way they felt, and to be able to grasp them with appropriate pressure, because with original prosthetic limbs, it's very difficult to judge the pressure with which you are grasping objects. So a neural engineer in Italy, and along with the Swiss Federal Institute of Technology in Switzerland, worked together on this new false hand for this man. And the way that they set it up was by connecting touch sensors in the artificial hand to electrodes surgically embedded in the remaining nerves of his upper arm. So this device did require that he had some remaining nerves left in his arm. Now, computer algorithms then converted the signals that were received from the sensors into a form that the nerves could detect. And so it was as if the nerves themselves were receiving signals from an original hand. Because of this, Dennis was able to feel as if he was using his original hand, grasp objects as if he was, and really live a much better life. He was able to operate on a daily basis as if he's not someone who has lost his hand. In the future, what they want to be able to do with this device is to make it fully implantable under the skin. The electrodes were surgically embedded, however, there were still parts of the prosthetic that were outside of the skin. This could cause the device to be easily damaged and makes it less attractive aesthetically as well. So these are the future directions, however, this was a huge step in the idea of bionic prosthetics.
I will be explaining the process of neural interfacing. The input would be the brain signals collected by electrodes. Action potentials and voltages across areas of the cortex are some of the signals that will be collected. Then these signals are computationally analyzed using sorting algorithms or spike detections. Then the data is decoded by neurons that communicate with each other using electrical signals and oscillations at the same frequency, or Bayes' theorem. Then the output would be action produced by these signals based on the data. As you can see in this picture, the electrodes are on the brain and they collect the data, which is then analyzed and decoded, and then finally produced into a graph so that it could be depicted by the person. So the current way of interfacing is using external BCIs, or brain-computer interfacing, but the next step that we should be taking is using an implantable chip that is invasive. So there's a chip that was created by Nanyang Technical University, or NTU, where they made a chip that was implanted into the cortex of the brain, and the transmissions of data were collected with accuracy. Some of the problems with other prototypes has been battery recharging / enlarging the power source due to large amounts of data that are wirelessly transmitted. So their solution to this problem was to analyze the signals in the brain before compressing them and transmitting them to the receiver, and this reduced the amount of data that was sent wirelessly. As you can see, here is a depiction of the chip, and it can aid in things such as nervous system / prosthetic communication, Parkinson's disease, Alzheimer's, and schizophrenia.
How a prosthetic hand is able to feel is through somatosensory feedback. Signals from sensors on a prosthetic hand are converted into intracortical microstimulation, and the neurons in the somatosensory cortex of the brain are stimulated. This intracortical microstimulation sends information that you need to know to successfully pick up an object. So that means the contact location, so you know what parts of the hand make contact with the object. Pressure, to know how much pressure to apply so an object doesn't slip from your grasp but isn't crushed. And timing, so that you don't overreach and you know exactly when to terminate the action. To test if the intracortical microstimulation would be able to send this information, research was conducted on animals to see if they could detect changes and feel a poke on the skin. In the localization test, an animal was trained to be able to discriminate between the location of pokes applied to their skin. The animal would be poked twice, and they had to report if the second poke was on the right or the left of the first poke. After a month of this training, electrode arrays were implanted and mapped to their receptive fields in the brain. A new experiment called a hybrid trial would replace 2 of a series of 4 pokes with the intracortical microstimulation. The bar graph shows that the hybrid trials had similar results to the mechanical trials. The contact pressure test trained animals to perform a tactile detection test and a pressure discrimination test. In the detection task, there were 2 stimulus intervals where a poke would be delivered, and the animal had to report back which of the 2 intervals they received the poke in. In the discrimination task, the animals would receive 2 pokes, and they would have to report which poke was stronger. In Figure C, the results of the test show that with an increase in amplitude of the poke, the percentage of correct responses increases. There were similar results for both the prosthetic finger and the native finger of the animal. The heat map shows that the neuronal activation in the cortex when the pinky finger is touched with 4 different amplitudes. And Figure B shows that the amplitude for a poke was equal to the amplitude of the intracortical microstimulation. These experiments show that intracortical microstimulation can be used to help prosthetic hands feel.
Okay, so now that we've explained how these prosthetic works and the new technology behind them, I'm going to touch a little bit on why this is so important. It's one thing to understand the technology and to create the technology, but the most important is how it impacts our society, especially in the medical world. So the reason that this is such a big step in technology and medicine is because people who have lost their limbs are not able to live life as normal as they were prior. These people now have limbs that do not feel as if they normally would. They cannot feel the hand of someone in theirs. They cannot grasp objects as they normally could. And this is a huge impact on their lives. In order to restore something that someone believes they have permanently lost, such as the ability to use their own hands or their own legs, is incredible in these people's lives. Here they think that they may never regain this feeling, but we are giving them the option to. This is not only physically life-changing for these people, but also emotionally life-changing for these people. It completely changes their entire life and is incredibly important to our world. And this is the whole point of why we try to improve our medical world. It's not only to broaden our knowledge on our bodies and on technology, but also to change the lives of others for the better.